Hey guys, what's up? Okay, so let's see. This is a talk that I have given in the Ágiles 2015. Ágiles is the Latin American Agile Conference. It was the eighth edition. It happens usually in October, every October, and this year was hosted in Uruguay. So out of the kind of 200 session proposals that were submitted. Around 50 were selected, 40 something, and I was lucky enough to get selected to speak about about Git, right? It says Git is not just a pretty face. That's the name of the talk. And it's kind of not related to explain Git itself as a versioning tool, but towards using Git as an automation tool. So that was that. I mean that was the. I mean the driver of the talk was given I happen to assist development teams. The adoption of Git is increasing, of course, as you might imagine, which is great. But not everybody, not every team is using Git with all the power that it carries on. I'm not gonna say everybody or every team, but most of the teams are just limited to using the versioning piece. Actually, the main piece, but the intention is to uncover other features that trigger some ideas, right? Basically, for every context, for every project, it might fit some needs or some other needs. Okay, so this was a talk within one of the technical tracks. So basically, there's a lot of information here. I'm not gonna uncover, or I'm not gonna, discover powder, but or gunpowder, but basically there's a lot being said already. So this is kind of more summarizing, putting things together, and showing a demo as well. Okay. So first of all, the my idea was to level the audience, right? I didn't, but at that point, I didn't know how familiar the audience was with Git itself, right? I mean, a distributed versioning system. So I was kind of explaining what's the main difference between a centralized versioning system like Subversion, CVS, versus a distributed distributed system like Git Mercurial, kind of the new way of developing, right? So when you're working in a traditional centralized way, basically every developer here in yellow, dev A, B, and C, they just talk to a single database and pull like a working copy of the repository at some point in time, right? So basically, all the operations will actually occur by talking to the server. And since the server is the one hosting everything, all the history of the files and all that kind of stuff, there is a single point of failure, right? If the server for some reason goes down, if there's a catastrophe or whatever happens to that hardware or software, basically we lose the entire history of the repository. Given you're talking to the server for most of the operations, working offline, it's kind of tricky. So yeah, I'm not gonna say I'm not gonna say impossible, but anyway, every operation that you need to go to the server. If you don't have connectivity, it will be kind of difficult to accomplish. Same thing, speed, right? There is a latency implicit when you're talking to a different node from your computer to the server, so speed could be or it's not ideal. And usually merging and branching, if you're familiar with centralized system, it's that happens not too often. Happens on the server. It's usually a very big pain or painful task. So it's complicated, right? So in opposition to all that, in a distributed system here in Red, basically the way you start is let's say developer A decided to start a project, so you actually create the repository on your own computer, right? So you start doing all the operations locally. That means you are not talking to any server. All the operations are happening locally. So your commits, your merging, your branching, everything happens on on your computer as a developer. So at some point when a developer at B or C or anybody else wants to start contributing, interacting, you basically clone the repository so you get an exact copy of the developer A's repository in this case, right? So the second developer will do the same, will do all the operations locally, committing the files, and all that kind of stuff. And at some point, they actually sync up the repositories. So given there is no server involved, and let's say developer A is working and he drops his computer, no longer good, you can basically clone back developer B's repository and you're back on track. All the history are not lost. So every developer's computer with a clone repository has the exact same copy. Of course, if you're continually building stuff, the only thing you'll be missing is from the last time you have sync up repositories, right? But anyway, given all everything happens locally, speed is very good. Merging and branching are kind of often tasks that you do. There is a flow, right? I mean, when you're working out of a, I don't know, of a master branch, or I don't know, develop. Let's say you're already in production, so your master branch is synced up with your production environment. So you're working out of a development branch. So when you get to work on a new feature, you actually branch out of that develop branch. You do your stuff, and when those are good, you merge back to develop. So the merging, and the branching, sorry, you can be branching code many times on just one day. So and since you're doing that often, conflicts and all that kind of stuff, I'm not gonna say they don't happen, but they are a lot. They go away a lot, and when they do appear, basically they're just very easy to fix. And given you're syncing up code with different computers, you're basically associating multiple repos. So these three boxes layout that I just draw is like from the theoretical point of view, right? But if developer A needs to sync up with developer B's repository, you have to have the computers be visible to each other, right? And that's kind of not a very realistic scenario. So usually what you do is use like a common repository, like a like like GitHub or inner source or any central repository that you can have that repo exposed to the internet or exposed to the developers, and then apply all the security over there. So basically when I'm talking to associating multiple repos, at some point you might be having configured other developers' repository as your remote. You might have your common repository as a different remote, and with all the cloud hosting that happens today, like Heroku, App Harbor, whatever hosting you do, most of them, the way they work is you just push code to a Git repository on those VMs or whatever, VPS, dynos, whatever you have over there, and you basically associating another remote repository over there. So at some point, you have multiple repositories syncing up with yours, which in a centralized layout is kind of impossible to replicate. So I actually spend my time talking about this now that in the talk itself there was just the intention was for this just to be an overview of and the main difference of the two. So actually, yeah, why you're here for? I was not there to talk about Git itself and how it works, but more towards hooks. This case, right? So basically, what are Git hooks? Hooks, like it says over there, are little scripts to trigger actions on certain points, right? A typical developer workflow would be adding code to the staging area, right, to the index area in a Git repository, and then you commit code to your head. Then you, I don't know, check out, you merge, you branch, all that kind of all those points in the typical workflow. You might have an action to be triggered. Okay, so as any other script, I mean, as long as you can use any scripting language and as long as they are executed, you can trigger basically whatever you want, whatever the context might define, and it's limited to the team imagination, I don't know, or creativity, right? So there's a lot of Git hooks. For instance, luckily they are very self-descriptive. So we can see over here there is a pre-commit and a post-commit, which means by the time you're committing code, a little bit before the actual commit gets done, with a pre-commit hook, you can actually do something specific for you, right? And same way with a post-commit hook, you might be trigger something right after the commit has happened. So I don't know, usually all the posts are used to either deploy code, send notifications, right? So because again, that happens right after the actual action execution, right? So not all of the commands has a pre and a post. Some of them are just the pre, some of them are just the post, and that's the way it is. So if you look at the Pro Git book by Scott Chacon, I had the opportunity to meet him and talk to him in the RubyConf here in Buenos Aires, 2011, I think it was, the first edition of the RubyConf. He was here with a few other celebrities, I guess, Aaron Patterson, a lot of cool people. But anyway, basically, in his book, he divide all the or categorize the hooks in basically two main areas, right? The yellow over here are the server-side hooks, and the orange are the client-side hooks. It sounds kind of crazy, right? Because we're saying that in a distributed model, you don't have the server figure, right? So basically, what he means by client-side hooks are those hooks that executes on the developer's computer, right? On the committer's computer. And the server side, the yellow ones, are hooks that you trigger when you're interacting with another repository. So basically, when you're syncing up, right? When you're pushing code from to a remote repository, you want things to happen over there on the destination repository, right? So that's the difference between client and server side hooks. And same, even that. I mean, for the client side, he divided the hooks in three areas, right? These top left hooks are called committing workflow hooks, just because they happen around a commit. You can check for a message, I don't know, run something before the commit or after, whatever. The second are the top right corner, which are when you're applying email patches over there. I never get a chance to work like that with email patches, but as far as I know, the Linux kernel works that way. And then these at the bottom are just the others. So he says there is a committing workflow hooks, the email workflow hooks, and the others, which are basically checkout, merge, push. So these are the separation or logical separation he states on the hooks. So speaking of practical cases, I was kind of looking over what examples I might give, or what are the practical use cases, right? So when I was looking for examples, I saw that in the AngularJS GitHub page repository, if you're looking at the README, the Angular team uses a specific format for the commit message, right? It says it has to have a type, which by type it means if it's a feature, if it's a fix, if it's documentation, styling, whatever, and the scope where the actual change is happening, a subject and a blank line. So why they're doing that? Because based on the commit message, they actually run some tools and generate documentation. Yeah, they generate the change log, they generate the release notes, and basically that's what the team has defined, right? So if you're contributing a patch or something to the Angular team, you end up, I don't know, creating a pull request, and then at some point somebody might be looking at the pull request, looking at the commits, looking at the message to see if they're properly formatted. I have no idea how they are doing that, but if that's something that you have to do on a frequent, like often, manual. So as you all know, everything that you do manually, it's error prone. So there is some risk involved that you might be, I don't know, tired and not seeing something, and something just went through what it shouldn't have gone. So it would be very easy here to create a Git hook with a very simple script to check actually if the commit message is properly formatted, right? So you would do something over with either the pre-commit or the actually commit message hook, and you can actually reject the commit if it's actually not valid. So this is one good example of how you would do or using the one of the hooks. As a second example, I was looking that GitHub has implemented what they call the protected branches, and this is a very new feature. If you look at the timestamp of this blog post, it's from last month. And basically, what they do, or what you can do as an owner of a repository, is flag some of your branches to be protected, so you can avoid any Git force push being done to the branch. So again, if you're not using GitHub on your day-to-day activities, but you want to replicate this in your own local context with your team, basically you can use a Git hook with a in a post receive, or you can actually check which command has triggered the hook, which argument was given in this case to the push. So if you detect there is a dash F or dash dash force, and if you could check to which branch you're actually the push is actually it's actually happening, you could be able to reject the push. Okay, so I didn't mention it before, but on the key hooks has some of them has arguments kind of out of the box. For example, the commit message. One of the arguments that you receive within the script is the message itself. Sometimes you might receive which git command is triggering the hook, because I don't know, it might be triggered with two different commands, or you could eventually use environment variables, I don't know, to get the logged in user. So it's very flexible. Just anything you can do with scripting, it's something that you could put inside a hook and automate it. Okay, so that was basically it from the with the slides. The rest of the time I was kind of willing to show some of the hooks in action. So let's see. The layout I was putting together is basically three different repositories, right? One repository as a like it would be like the developer's computer, one common repository where you will be pushing code, and then one like I don't know, test environment, something where you would deploy code when it's actually happening. So the three the three statements we want to accomplish through hooks is basically assure that no coding standards are being violated when you're doing a commit. The second one is making sure the code coverage is not going below a threshold when you're actually pushing code to the repo, to the common repo. And the third one is deploying automatically to an station environment when you're pushing, right? Basically, just do an auto deploy to the test server. So the application, the web app that we were using is it's the actual call for papers platform that's been used for the conference, which I wrote with some other guys from the community. Basically, it's a Ruby application. It's a Rails application, and the scripting that we will be doing it's also in Ruby. Just I don't know. For those that are not familiar, it's easy to read. I mean, rather than scripting in Bash. So let's see. Let me open the. Let's open the app. So I'm gonna start it, and I'm gonna show here what the app. It's not the scope is not to. There you go. There you go. Puma takes some time to start the workers. So basically this is the app. Nothing fancy. We're not gonna get into there. This is just dummy session proposals. And as you see, this is listening on port 3000, which is Rails default port. Okay, so the hooks are within, let's open the code for that. Okay, so basically this is the local repository where we will be working locally. So the hooks for this repository are within the Git folder, right? So basically this Git folder, it's present on every Git repository and basically hosts all the history of the changes, right? When you do a git init on a directory, basically that gets created. There is a subdirectory within there that has another one with the hooks. That again, it's kind of, it comes for free right out of the box when you initialize a repository. So let's open those. So these are, these are the hooks that you get. You just have to rename it to sample and then maybe do a give executable permissions, and you're good to go. So for the sake of time, I just created this one pre-commit with the Shiba and with Ruby, and it already has executable rights. So the first thing that we would do, we were saying that we wanted to check for coding standards, right? For that, I will be using a Ruby gem called Rubocop, which is basically based on the Ruby community, on what the coding standards are defined by them. That doesn't mean that you cannot configure the Rubocop gem with your own needs. Of course, you can do that, but I'm not gonna get into that. I'm just gonna run it the way it comes. So let's open one file that okay, so let's do that. Okay, let's inject some crap, sorry, and let's run the files over there. Okay, so the very first thing I want to do, if I want to check for the coding, the coding standards on the files that I'm changing and I'm putting into the next commit, is first figure out which are those files. Okay, so first I'm gonna list the files, right? I'm gonna just run a git status with a machine friendly output so I can parse the file names and just holds the one that are Ruby extensions. This is because I'm just gonna run Rubocop, right? If I'm changing JavaScript files, and I could use the Google coding standards, and I should find a Ruby gem that I can, or maybe not Ruby gem, I can just use Bash and check against those files against the Google coding standards. Okay, but for this case, I mean, this is just for the sake of simplicity of the demo, I'm just gonna run only the Ruby files. Okay. So once I have the files, the command I'm gonna run is Rubocop. Okay, I'm gonna run the command, just passing the files, and I'm gonna output the results on a JSON file. Why is that? If everything goes fine, I'm just gonna print OK and we're good. And if something goes wrong, I'm just gonna do some dummy parsing of that file so I can print on the standard output how many offenses has been detected. Okay, and the exit status is actually the status of the Rubocop. So if Rubocop fails, I'm just gonna exit with that. If it goes fine, I'm gonna exit with a 0 code. And since this is a pre-star hook, you could exit with a non-zero status and have the workflow to be interrupted. Okay, so if this is a non-zero output, the commit will never get accepted. Okay, so that's it. I have changed the file. So that's the file I have changed. Let's do a git add, and let's do a git commit. Space. You see that the code analysis has been triggered, and it says 2 offenses has been detected. The Robocop JSON file is where I can have extra information, so I'm gonna go back to the repository, and if I hit Command Control J, yeah, there you go. It says unnecessary space detected, and one line is too long. Okay, so basically that's what I have changed. I'm gonna just remove that space, and I'm gonna split this line into 2. I'm gonna close this out because I don't want it. And I'm gonna do this again. Okay, sorry. Fix offenses. Boom. Run code analysis. Everything went okay. So let's move to the second one, to the second premise, which was to making sure the code coverage is not going below a threshold. So for that, when I'm pushing, right? When I'm pushing code. So for that, we're gonna use the git push, and in order to check for the code coverage, I need to run the test first. So again, this is a Ruby app. Most of the tests are run with RSpec. It's a Rails app with but it's also an SPA. I mean, there's Angular involved on the front end, which there are some Jasmine and protractor tests. But again, we're not gonna worry about that now. Let's run RSpec. So this is just a dummy progress bar, and I'm gonna run only the mailers spec and not everything, just because if I run everything, it will take some time, kind of, I don't know, 20 seconds, because the test will spin up some Elasticsearch nodes, and then there's some tests against the nodes, and I don't know, it takes some time. So let's just focus on the mailers. I mean, we can make the point just by testing that. So once we got the specs run, if a test is failing, I'm just gonna say you cannot push with a failing test, and if that goes okay, I'm gonna set the threshold to 99, and I'm gonna parse this output file, and I'm gonna exit with 1 if the actual result is below 99 in this case. Okay, so I don't know, let's take this file, and I'm gonna make this test fail. And I'm gonna try to push. Okay, git push. It's gonna run the specs. And it fails because I mean, it's not pushing because there's a failing test. This took some time because Spring was not started. Next time it will take shorter. Okay, so let's revert that change on the test, so it passes now. let's say fix spec, git push, and say enable to push because the code coverage is at 70%. 70% is because I'm only running the specs of the mailer, right? So believe me, the code coverage is pretty good, around 90, 97, 98. But since I'm just running mailers, it's of course below that. So let's change this to 69 so it actually pass. I mean the push is allowed. Let's push again. So now everything went fine. I pushed the changes to the central repository. So the next thing that we need to do is the act to deploy. But for that, I'm gonna pause the video because I really need to run. I didn't realize what's the time. So I promise when I get back, I just do the final piece of the demo, and we're gonna be good to go. All right. So we'll be back soon. I'm back. So the third and last thing that we wanted to cover was to do an automated deployment to the testing environment, right? So through a git push. I don't think I mentioned it before, but in the conference, so I didn't rely on the internet connection. So I'm putting together this common scenario, but the actual developer's workstation is actually the computer, but the common repository is sitting on a different machine, and the environment, the testing environment, is on a different machine, right? So for me to not depend on latency and connectivity and that kind of funny stuff, I put everything together, right? I simulate the three different boxes on my computer. So one directory is the the developers repository, another directory is the common repository, and another directory is the the actual server, right? The testing environment. So let's see. So this is the actual common repository that I'm pushing code to. So this is a bare repository, right? So there is no like a working directory. It's just the repository. So you can see there the hooks folder, and that's what I'm gonna open, or I'm gonna open this, and we can see the hooks over here. So these are in this case, the server-side hooks, right, that I want to trigger when I'm doing an action from my local workstation repository. So I'm going to be using the post receive hook, which upon accepting the push, it's going to do something. In this case, deploying code. So let's open the actual server, right? The one it's simulating the server. This is another, of course, I mean, it's the same application. Is the only difference is just listening on port, sorry, port 5000. Okay, so let's open that. Let's give some time to Puma to start again. And that should spin up the server in our case, right? So this is where I'm gonna see the changes that I've done locally over there. So, so we have a server running. So the first thing we want to do on this hook when I'm pushing go is stop the server. Okay, so I'm gonna kill that process or those processes, because this is actually the Puma worker or the Puma process and the two workers that depend on that one, the Elasticsearch cluster. So there's many processes involved, and I'm gonna kill. After I kill, I'm gonna be pulling the code from the common repository into this one. This is just, I can do many things here, right? I can do a clone and like kind of back up the old one, do a clone and start over. I'm just gonna do a pull here, right? If everything goes good, I'm just gonna say we're good. If something goes wrong, I'm just gonna do a reset hard and bring back the old version. Okay, so finally, and then I'm gonna start the server once again. If you notice here, there is no exit code because this is a post, right? Post start hook, which this will not interrupt any workflow or anything. Like I said before, post hooks are kind of used for this, deploy, post deploy activities, or send notifications, email, trigger, all that kind of stuff. So that's what we need to do as far as the hook. So let's go back to our local repository. Let's open style sheets, which are kind of easy to show the changes. Okay, I'm gonna change one of the bootstrap global variables. Okay, I'm gonna change the primary to orange, and I'm gonna refresh here. Primary is this blue color. As you see here, I changed it to orange, and of course if I refresh here, it will still be on blue, right? I've done nothing to change that yet. Okay, so I'm gonna go back to my local repo, which is this one, and I'm gonna do the primary color. I'm gonna do a git push. It's running the specs. Push the code and kick off deployment, right? This is what we've done on the hook. Kick off deployment, done a pull, changes accepted, app started. So if I now go back to port 5000, my server, do a refresh, and I can see the changes reflected. Okay. I could do many things here. A typical Rails application, you bundle the Ruby gems, you do migration of the database schema. Let's try the bundle. Install. Okay, and let's go back to revert this. I get rid of that, and I'm gonna refresh my local instance 3000. Went back to blue. Do a push to the server, running the specs. This is one of the other things that you probably do on the server, right? Running the specs, making sure that the coverage is still good. Maybe not on a post receive, but on a pre receive, so that you can reject the push. Actually, okay. So here's the bundle. happening. So kick off. I've done, of course, it's nothing being installed because I have all the gem installed. But if I was adding a new gem, this will install on this gem set as well. So update accepted. I refresh my server and everything should go back to blue. Okay. All right. So that was actually the entire talk. The conclusion I was kind of, when I was wrapping up everything here, was in the conference you have people coming from all over, right? So some people might be using, I don't know, tools like Travis, like I don't know, CodeClimate, like open source tools that will help all this process being automated with I don't know, basically no effort, rather than just configuring the one time to the tools or one time activity, right? But for other scenarios, and maybe like ours, it's not a possibility for us to leverage those kind of tools. And the kind of the message was, okay, if in your own context you cannot use those tools, just, I mean, don't be lazy saying I can't use those tools, so I cannot automate. Basically, go back to the basics, and using, for instance, Git hooks, you can basically automate and have your own deployment pipeline to do continuous delivery. So again, when you do a Git push, for instance, to Heroku, all the magic that you see happening over there, it's basically this. It's basically some scripting happening after hooks. Well, even when you're using GitHub and you're, I don't know, triggering a build in Travis CI, what are you doing? You're configuring a webhook. That's for the user interface, right? But behind the scenes, this is what's going on. Jenkins has an API where you can trigger builds through for example, a post HTTP post request. We've used that even here. That I was pushing code to a common repository, and then through an HTTP post request to Jenkins CI machine, we could actually do a pull of that Git repo and do all these kind of things, but maybe through Jenkins. So maybe more graphical, all the coverage, code coverage threshold, the bundle, the schema migrations, and all that. So anyway, that was it. Feedback is very welcome. Hope you enjoy it. Hope it trigger some ideas for your own context. So thanks for watching. Bye.